Hola, this is my Skill 6 video, and I have to prove trigonometric identities. So basically, this is the problem I chose. 1 minus 2 cosine squared x equals 1 minus cotangent squared x over 1 minus plus cotangent squared x. So I decided to manipulate this side, and I put cotangent in terms of cosine and sine, because it's easier to simplify this for me. And then so I got this because, cotangent is cosine over sine, and then I just rearranged the plus ones for organizational purposes. And then what I did is that I did the least common denominator rule, and so I multiplied 1. I did 1 multiplied by sine x over sine x, which is the same thing, and so then, therefore, I could add two fractions together on the top, and then I did the same thing on the bottom. So I got negative cosine squared x plus sine squared x over sine squared x divided by cosine squared x plus sine squared x divided by sine squared x. So now I have a fraction divided by a fraction. So essentially what I did is I just multiplied it. So I did like the copy, change, flip method, and I just multiplied it by the reciprocal. And with this, I got a sine squared x on the top and on the bottom, so I was able to cancel it out. So then I'm left with this negative cosine squared x plus sine squared x and this cosine squared x plus sine squared x. Now, since I couldn't do anything more without using a trig identity, I used the simple Pythag trig identity, which is cosine squared x plus sine squared x equals 1. And that directly corresponds to my denominator. So literally that denominator equals 1. And this just shows my thought process. So I'm basically just left with the numerator over 1, which is just the numerator. And that equals negative cosine squared x plus sine squared x. Now, again, I used the same trig identity. I just manipulated it in a different way. And I manipulated it into sine squared x equals 1 minus cosine squared x. And again, it's still using the same trig identity. And I did this because I wanted it in terms of cosine squared x. Like, I want that to be my final answer. So I'm going to substitute something in for sine squared x. And like I could have solved it doing like cosine squared x equals minus sine squared x plus 1, but that wouldn't really help me in my problem because I'm trying to get it to equal this thing over here. And so essentially, once I again manipulate the identity, I then substitute sine squared x into the equation I was left with at the last step, and I get negative cosine squared x plus 1 minus cosine squared x, and that gives me negative 2 cosine squared x plus 1, just rearranged this, and therefore this equals this, and this trig identity is true. Ta-da!